Metric weights are also called K-values. The defaults are all zeros except K1 and K3, which equal 1. Roughly, this translates to using least bandwidth and cumulative delay to calculate the metric. In this case, delay is in tens of microseconds. Click the first button to see the commands. K-values are configured together on one line in router configuration mode, with the syntax shown in the slide. Click the next button. To verify, use either Show IP EIGRP topology or Show IP protocols. We will continue our discussion on metric weights in the next slide. Cisco recommends against using K-values K2, K4, and K5. These deal with load and reliability. Notice that bandwidth and delay are for a particular interface, but load and reliability are for the entire router. Load and reliability are calculated values and change over time. However, a change in a K value causes a resync of all the router interfaces. This means that EIGRP updates are sent each time the K values change, potentially causing routers to continually choose different routes. This is called route flapping. K values must match in order for a neighbor adjacency to be active. Click the button on the screen to view the message that will be displayed if there is a mismatch. Bandwidth and delay are for a specific interface, but load and reliability are for the entire router. Let us see how K values are used in the metric. To compute the metric, the K values are simply plugged into an equation along with the measures that apply to an entire route. The measures are least bandwidth, cumulative delay, worst load, and worst reliability. To display the values of these measures for one interface, use the Show Interface command. Click the button to see the output. Notice that there are two values for load: TX load, the transmit load, and RX load, the receive load. Maximum transmission unit, MTU, and hop count, 0 if a connected subnet, are also transmitted with the EIGRP update, but are not actually used in the metric calculations. Let us look into the default values for bandwidth and delay in the next slide. It was seen that the default metric is based on the bandwidth and delay on an interface. The interface defaults with delay in tens of microseconds are shown in the table on the slide. A serial interface has a default bandwidth of 1544 with a delay of 2000. For Ethernet, bandwidth is 10,000 and delay is 100. For fast Ethernet, bandwidth is 100,000 and delay is 10. For gigabit Ethernet, bandwidth is 1 million and delay is 1. For a loopback, bandwidth is 8 million and delay is 500. In the next slide, we will find out how to configure bandwidth and delay. Click each command to see the actions performed. This is the command that you use to reset the bandwidth. This is the command that you use to reset the delay. If you prefix the bandwidth or delay commands with no, this resets the values to default. Note that the bandwidth is in kilobits per second, and the delay is in tens of microseconds. Click the last two command buttons. Click the next button. Note that the delay is displayed in tens of microseconds for the Show interface, Show IP EIGRP topology, and Show IP EIGRP topology commands. Next, we will learn about the tables maintained by EIGRP.